Section 13.2, Health Probes with Spring Boot Actuator and Kubernetes. Once an application is deployed, how can we tell if it's healthy? Is it capable of handling new requests? Did it enter a faulty state? Cloud-native applications should provide information about their health so that monitoring tools and deployment platforms can detect when there's something wrong and act accordingly. We need dedicated health endpoints to check on the status of the application and any components or services it might use. The deployment platform can periodically invoke health endpoints exposed by applications. A monitoring tool could trigger an alert or a notification when an application instance is unhealthy. In the case of Kubernetes, the platform will check the health endpoints and automatically replace the faulty instance or temporarily stop sending traffic to it until it's ready to handle new requests again. For Spring Boot applications, you can leverage the Actuator library to expose information about their health through a /actuator/health HTTP endpoint, including details about the application's status and the components in use, like databases, event brokers, and config servers. Spring Boot Actuator is a useful library, providing many endpoints for monitoring and managing Spring Boot applications. Such endpoints can be exposed through HTTP or JMX, but either way we must protect them from unauthorized access. We'll limit ourselves to using the HTTP endpoints, so we can use Spring Security to define access policies like those for any other endpoint we've worked with so far. This section will cover configuring health endpoints in Spring Boot applications using Actuator. You'll then see how you can define liveness and readiness probes so Kubernetes can use its self-healing functionality. Section 13.2.1, Defining Health Probes for Spring Boot Applications using Actuator. First of all, open the build.gradle file in the Catalog Service project, Catalog Service, and ensure that it contains a dependency on Spring Boot Actuator. We used it in Chapter 4 for refreshing configuration at runtime.
Listing 13.5, Adding dependency for Spring Boot Actuator in Catalog Service.
There are a few viable solutions for protecting the Spring Boot Actuator endpoints. For example, you could enable HTTP basic authentication just for the Actuator endpoints, while all the others will keep using OpenID Connect and OAuth 2. For simplicity, in the Polar Bookshop system, we'll keep the Actuator endpoints unauthenticated from inside the Kubernetes cluster and block any access to them from the outside, as you'll see in Chapter 15. Warning: in a real production scenario, I would recommend protecting access to the Actuator endpoints even from within the cluster. Go to the Security Config class of your Catalog Service project and update the Spring Security configuration to allow unauthenticated access to the Spring Boot Actuator endpoints.
Listing 13.6, Allowing unauthenticated access to the Actuator endpoints.
Finally, open the application.yml file in your Catalog Service project, Catalog Service, and configure Actuator to expose the health HTTP endpoint. If you followed the examples in Chapter 4, you might have an existing configuration for the refresh endpoint. In that case, go ahead and replace it with the health endpoint.
Listing 13.7, Exposing the health Actuator endpoint.
Let's check the result. First, we need to run all the backing services used by Catalog Service, Config Service, Keycloak, and PostgreSQL. We'll run them as containers. Package config service as a container image, /radlew boot build image. Then open a terminal window, navigate to the folder where you keep your Docker Compose file, polar deployment/docker, and run the following command.
See this code.
After ensuring that all the containers are ready, run Catalog Service on the JVM/gradlew boot run, open a terminal window, and send an HTTP GET request to the health endpoint.
See this code.
The endpoint will return the overall health status for the Catalog Service application, which can be one of up, out, _ service, down, or unknown. When the health status is up, the endpoint returns a 200 OK response. If it's not, it produces a 503 service unavailable response.
See this code.
By default, Spring Boot Actuator only returns the overall health status. Through application properties, however, you can make it provide more specific information regarding several components used by the application. To better protect access to this kind of information, you can enable showing health details and components always, or only when the request is authorized. when _authorized. Since we're not protecting the actuator endpoints at the application level, let's make the extra information always available.
Listing 13.8. Configuring the health endpoint to expose more information.
Once again, rerun catalog service /gradle boot run and send an HTTP GET request to localhost 9001 actuator health. This time, the resulting JSON object contains more detailed information about the application's health. Here's a partial result as an example.
See this code.
The generic health endpoint provided by Spring Boot Actuator is useful for monitoring and configuring alerts or notifications, since it contains details regarding both the application and the integration with its backing services. In the next section, you'll see how to expose more specific information that's used by a deployment platform like Kubernetes to manage containers. Before moving on, stop the application process, Control-C, but keep all the current containers running. You'll need them soon. Section 13.2.2, Configuring Health Probes in Spring Boot and Kubernetes. Besides showing detailed information about the application's health, Spring Boot Actuator automatically detects when the application runs on a Kubernetes environment and enables the health probes to return liveness /actuator/health/liveness and readiness /actuator/health/readiness states, as illustrated in Figure 13.4. Liveness state. When an application is not live, this means it has entered a faulty internal state from which it won't recover. By default, Kubernetes will try restarting it to fix the problem. Readiness state. When an application is not ready, this means it can't process new requests, either because it's still initializing all its components during the startup phase, or because it's overloaded. Kubernetes will stop forwarding requests to that instance until it's ready to accept new requests again.
Figure 13.4. Kubernetes uses liveness and readiness probes to accomplish its self-healing features in case of failures.
Customizing liveness and readiness probes. To extend support for the health probes in any environment, you can configure Spring Boot Actuator through the dedicated properties. Open the Catalog Service project, Catalog Service, and update the application.yml file as follows.
Listing 13.9. Enabling liveness and readiness probes in any environment.
Let's check the result. All the backing services for Catalog Service should be up and running on Docker from the previous section. If not, go back and follow the instructions to start them all. Docker compose up-d config service polar postgres polar keycloak. Then run Catalog Service on the JVM /gradle boot run and invoke the endpoint for the liveness probe.
See this code?
The liveness state of a Spring Boot application indicates whether it's in a correct or broken internal state. If the Spring application context has started successfully, the internal state is valid. It doesn't depend on any external components. Otherwise, it will cause cascading failures, since Kubernetes will try to restart the broken instances. Finally, check the result for the readiness probe endpoint.
See this code?
The readiness state of a Spring Boot application indicates whether it's ready to accept traffic and process new requests. During the startup phase or graceful shutdown, the application is not ready and will refuse any requests. It might also become temporarily not ready if at some point it's overloaded. When it's not ready, Kubernetes will not send any traffic to the application instance. When you're done testing the health endpoints, stop the application, Control-C, and the containers, Docker compose down. Note: go ahead and add Spring Boot Actuator to all the applications composing the Polar Bookshop system. In Order Service and Edge Service, remember to configure unauthenticated access to the Actuator endpoints in the Security Config class, as we did for Catalog Service. In Dispatcher Service, you'll also need to add a dependency on Spring Webflux, org.springframework.boot Spring Boot Starter Webflux, because Actuator needs a web server configured to serve its endpoints over HTTP. Then configure the health endpoints for all the applications, as you learned in this section. As a reference, you can look at the source code repository accompanying this book, Chapter 13/13end. By default, the readiness probe in Spring Boot doesn't depend on any external components. You can decide whether any external systems should be included in the readiness probe. For example, catalog service is an external system for order service. Should you include it in the readiness probe? Since order service adopts resilience patterns to deal with the scenario where catalog service is unavailable, you should keep catalog service out of the readiness probe. When it's not available, order service will keep working correctly, but with graceful functionality degradation. Let's consider another example. Edge service depends on Redis for storing and retrieving web session data. Should you include it in the readiness probe? Since Edge service can't process any new requests without accessing Redis, including Redis in the readiness probe might be a good idea. Spring Boot Actuator will consider both the internal state of the application and the integration with Redis to determine whether the application is ready to accept new requests. In the Edge Service project, Edge Service, open the application.yml file and define which indicators to use in the readiness probe, the application standard readiness state and the Redis health status. I'll assume you have already added Spring Boot Actuator to Edge Service and configured the health endpoints as described earlier.
Listing 13.10, including Redis in the computation of the readiness state.
Configuring liveness and readiness probes in Kubernetes. Kubernetes relies on the health probes, liveness and readiness, to accomplish its tasks as a container orchestrator. For example, when the desired state of an application is to have 3 replicas, Kubernetes ensures there are always 3 application instances running. If any of them doesn't return a 200 response from the liveness probe, Kubernetes will restart it. When starting or upgrading an application instance, we'd like the process to happen without downtime for the user. Therefore, Kubernetes will not enable an instance in the load balancer until it's ready to accept new requests, when Kubernetes gets a 200 response from the readiness probe. Since liveness and readiness information is application-specific, Kubernetes needs the application itself to declare how to retrieve that information. Relying on Actuator, Spring Boot applications provide liveness and readiness probes as HTTP endpoints. Let's see how we can configure Kubernetes to use those endpoints for the health probes. In your catalog service project, catalog service, open the deployment manifest, k8s/deployment.yml, and update it with configuration for liveness and readiness probes as follows.
Listing 13.11, configuring liveness and readiness probes for catalog service.
Both probes can be configured so that Kubernetes will start using them after an initial delay seconds, and you can also define the frequency with which to invoke them, seconds. The initial delay should consider that the application will take a few seconds to start, and it will depend on the available computational resources. The polling period should not be too long, to reduce the time between the application instance entering a faulty state and the platform taking action to self-heal. Warning: if you run these examples on resource-constrained environments, you might need to adjust the initial delay and the polling frequency to allow the application more time to start and get ready to accept requests. You might need to do the same when running these examples on Apple Silicon computers until ARM64 support is part of Paquito build packs. You can follow the updates here. See this link. That's because AMD 64 container images are run on the Apple Silicon computers, ARM64, through a compatibility layer based on Rosetta, which impacts application startup time. Go ahead and configure the liveness and readiness probes in the deployment manifests for all the applications composing the Polar Bookshop system. As a reference, you can look at the source code repository accompanying this book, Chapter 13/13 end. On top of event logs, health information improves the information we can infer about the application's internal state, but it's not enough to achieve complete visibility. The following section will introduce the concept of metrics and how we can configure them in Spring Boot.